my god. Sorry. Okay. I didn't mean to open Visual Studio. This is memory intensive. I can see everything is just lagging. I'm trying to close it now. Christ. It's consuming a lot of memory. Oh. Wait, how many instances do I have opened? It's just one, so why is it not closing? Alright, my video is lagging. What's going on? It's not even about my internet. This is my computer suffering. And I don't know what do I need to do now? I think I need to free up some space on the computer. It's really dying right now. So, oh god, look at that. Awful. That was really bad. Anyways, I'll look into that later on. I don't know what to uninstall now, but we'll see. So, how about now? Smooth. Alright, let's go. One in the stream, open widgets. Alright, so let me get started. Today I would like to discuss linked list one more time, right? Go over the basics and solve two easy problems, right? That are a bit tricky, but very similar. So let's see what's a linked list to begin with. So a linked list is basically a sequence of nodes, connected to one another through their property, and that property is called the next property. So a linked list is basically a list of nodes, so like this. So we can have one here, which is a node in a linked list. This is another node, and they are connected to one another this way, right? Now usually the last item in the linked list is called the tail, and it's usually none, right? It points to nothing. Now each node in a linked list, right, is a class, or is an instance of a node class, right? And it's made up of two properties, right? So it has a value, right? A value which is equal to this value here, 1. I'll set it to 1. And the next property is simply going to be none at first. In its original form is none, but when it is part of a linked list, right, and there are other nodes attached in the linked list, right, the none value could point to the next node, right? It could point to this next node here, which is this value here. So the next property of this node here is this node here, and the next property of this node too is this node here, like that. So in simple form, right, or in a simple definition, linked list is simply a bunch of nodes, right? Nodes with properties like next and value, right? Through which it's a bunch of nodes connected to one another through their next property, which is this value here, this next here, right? So let me put it this way. So this is the next. So to add another node in a linked list, let me call this linked list X, right? This is a linked list X. If I were to add another node to this linked list, I'll have to add it through the next property of the previous node, right? Let's say this let's say I want to add a 4, right? A 4 or a node with a value 4 to this linked list X here, right? I'll have to replace the non property of this node here with the entire new node that I want to introduce in the linked list, right? So in that case, I'll have to do something like this. Sorry, I'll have to remove everything here and then replace it with my new node, right? So my new node will be 4 like this, and this 4 itself has a next property which is equal to none here, like this. So this is going to be none. So that's how we construct a linked list and connect values to each node in the linked list, right? So let's see that in application, or let's just look at it in practice. So I've done this before, but I would like to go over it again and show you how to add items to a linked list, how to remove an item from a linked list, how to reverse a linked list, right? How to get the middle of a linked list, how to I did a lot of things the other day. I should have started this. God. Anyway, so we had a lot of operation on linked lists. I've done a lot of operation on linked lists so far, so I'll just put revision here, right? I'll create a file called revision. Instead of creating a file, right, since I'll be revising, so I can just put a folder in it. I'll call that folder revision to make everything modular. So I'll say revision like this, and then I'll create a new file in this folder called I'll call this file linked list, or I'll say create or linked list basics. Let me call this linked dash list dash basics. Okay, so that's it. So we know, so to create a linked list, right, we need nodes, right? And we know our node has two properties, a value property and a next property. So it's essentially a class, right? The node is a class, so I'll create a class called node, right? Now this node class is going to be instantiated, so we need a constructor function, right? And this constructor function is going to take one property, right? I mean the value that we want to set our node to, right? So we know we'll have self dot value, which is going to simply equal to the value, and then we'll have self dot next, which is simply equal to the none. Sorry, the next value is going to be none. So now we need to start creating our linked list class. So I'll call this linked list. So this is our linked list, and here's what we need to do. First of all, we will need to instantiate this class, right, by creating the head of our linked list. So first of all, we need a constructor function, right? And this constructor function will not take anything, we'll just instantiate it like that, but we'll set a head for our linked list, right? Now our head is simply the first item in the linked list. Now in its neutral form, or in its first form, it's going to have a value of none. There is nothing in the head at first, right? It's simply going to be an empty list, but an empty linked list will still have a head, right? And the head of that empty linked list is simply going to be equal to none. So that is how we will create our first we'll instantiate our linked list, right, with a head. So it's going to start with a head. Like I said, the first item in a linked list is the head, right, which is this one here. This is the head. And yeah, so next we'll define a function to add items to our linked list. So I'll say define add nodes, right? Now the items we add to our linked list are called nodes, right? So I'll say add node, right? This node is simply going to have a value, right? Because we might want to add one to the linked list, right, which is simply a node, but then the node is if a class, right? It's a class, and it's just going to be an instance of the actual node class. So here's what we need to do. When we create this, we'll say new node. So new node is simply going to be equal to an instance of the node class. So I'll say node value, like this, right? So we'll pass in the node. We know the node, an instance of the node takes a value, right, which is this value here. So I just passed in the value we are adding to our linked list to that node. Now how do we add this node? I mean, we at this point we are simply instantiating the node, right? We've not added it to our linked list. Well, in a case where this node is the first node we are adding to our linked list, or in other words, our linked list has an empty head, right? We need to first of all add that node as our head, right? Or we need to check if our head has a node or it is none. So if self.head, right, is not none, right? If the head is not none, if the head is none, so if okay, I'll say if not self.head, right? I'll put this here. If not self.head, right, this will be our head. So I'll say self.head, right, is simply going to be equal to the new node, like this, right? And then we return. Now the reason why we need to return is to end, the session at this point, right? Since it's the first item we are adding to the linked list, we just need to stop so that no further operation take place, right? So the next thing to do is, if we had a head in our linked list, right, we will need to traverse towards the end of that head, or towards the point where a node has a value of none, or a next property set to none, before we then add a new node to the linked list. Now let me show you what I mean by that. So let's say our linked list is like this. Oh, come on. Let me do this. So let's say we have a linked list called I'll create a new linked list. This linked list is X, right? And X has one node, right? This is one node, and we know the next property of this node will be none, right? Now for us to insert another node to this X linked list, for it to, let's say we want to insert a 3, right? So for it to become 1 3 like this, right? 1 3 like this will be none, right? For us to add a new 3 node is going to look like this to our linked list here, right? We'll need to first of all check if our linked list has a head. Of course it has a head, and the head is 1, and the next property of this head is none. So if the next property of the head is none, then we'll know that the position at which to insert this new node will be at this position here, so at where the next appears, right? So we'll just take it like this and add it to this place, right? So now this might look like a straightforward process, but essentially what we are doing is we are traversing the nodes, right, in the linked list. So we are going from the beginning up to the point where we find a none value, or a node has a next property set to none. Or let's say we want to insert this new node to our linked list. Let's say we want to insert a 5, right? A 5 to our linked list. Always our nodes are going to be like this. It's just like this, right? So let's say we want to insert 5. This, both of these are the same, so I'm just going to delete one. So let's say we want to insert a 5 to our linked list, right? Like this. Want to insert a 5 at this position here, right, as our third element in the linked list. Well, we don't really know where this sorry, we don't really know where this node is in our linked list, right? We don't really know where it is until it's we need to start from the beginning until the point where that node is, right? We can't just simply access this node in the linked list. It's not like arrays where you have an item like this. Let's say inside arrays you have 1, 3, right? To access 3 here, you simply need to know the index at which it is, right? And in this case, 3 will be at index 1. Let me call this array y. So if you do y at index 1, you will get the value 3, right? So we don't have indexes in linked list. So for us to access an item in a linked list, we simply need to traverse the linked list starting from the first node all the way to the point where we find that value. And in our cases, we want to insert an item in the linked list or a node into our linked list. We simply need to traverse the beginning of the linked list all the way to the point where we get a node that has a next value set to none, right? And then we'll replace that none or the next value of that node with the new node we want to insert to our linked list, right? So this is what we'll have at the end of the day. So we'll just simply take this node here, right, carry it all the way to this point. I'll remove this none, right, and insert this value here. I'll just take this and put it like this, right? So that's how we'll begin to construct or add new items to our linked list. So yes, that's all we need to do. So I'll come here, right? Since we already have a head, let's just assume we had a head already. Now here's what we need to do. We simply need to say, okay, so we'll say our current node, right? I'll call this a current node just to keep track of the node we have. Oh, sorry. So this is going to be our current node, right? Our current node is going to be set to the head. I'll put it as the head of, so self.head, right? And then we'll begin traversing the head all the way to the point where there is a non-value. So since we are doing that, we'll say while current node dot next, right? While the current node has a next value, right? We'll simply say the current node, right, we'll set it to the next node. So current node dot next, and once we reach a point where the current node no longer has a next value, which means the current node's next value is none, we'll set that next value to our new node. So say current node, right, current node dot next will be set to the new node like this. Okay, so that's what we have for now. And yeah, so let's also see how we can print items from our node, from our linked list. So I'll say to print an item from the linked list, I'll create this function outside of the linked list class so that I can use it for other operations as well. So I'll say define print, I'll call this print linked list. Okay, I'll call this print list, right? Print list, and this function is going to take a head, right? It's going to take a head, and it's simply the head of our linked list, right? Come on, I don't like this cursor moving around. So how do we print the nodes in our linked list? Well, we simply need to take, I'll just say this is going to be current node again, current node, and set this to the head, right? This is going to be our head. And then here's what we need to do. we'll simply iterate from the head to the point where there is no more value to access. In other words, the next property of the last node, right, is set to none. So we'll say while Christ while the current node, right, then we'll say print. I'll simply print 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 the current node dot value, right. Let me make this an instance of the node class so we can access all the values here. So print node dot, you can see we have the value here, and then we'll set the end. I'll put end here, right, so that everything is on the same line. It's just going to be like this. Okay, and then we'll set the current node should be equal to the current node dot next. Right, so that's all we need to do. And so let's create an instance of our node class, of our linked list. So I'll say list is going to be equal, I'll say let me call it list with capital L. Yeah, list is simply equal to the linked list class, right. Now we don't need to pass it a value, we simply need to instantiate it like that, and then we'll begin to add nodes to our linked list, right. So I'll say list dot add, right, the add node. So we want to add one, and then I'll do this for, so one, I'll add 4 nodes. So this is going to be 4, this is going to be 3, this is going to be 2. Okay, so these are 4 nodes we added to our linked list. Each of these nodes will have the next property set to the following node, right. So let's print this and see how it looks. So to print it, I'll just say print list and pass it the head, right. This is going to be equal to the list like this. So this is our list dot head, sorry. List dot head. So let's print this and see. Now you can see every node are connected to the last one or the previous one, and the last node doesn't have anything in front of it. Essentially what is there is none, right. So if I had this function within the linked list class, you would have seen the none at the end, but I just put it outside here, so which really means we're not going to access that none value of the last node. Okay, so alright, so that's all we need to do to create a linked list. So let's see what other operations can we perform on the linked list. We can unfortunately I did write down the operations I'll be having on this linked list today, but let's say we want to get the let's say we want to get a value by position. These are just really basic stuff. You can get the link to this in the GitHub repo. So to get the value by to get a position of a node in a linked list, right, you simply need to set a count, right, or position. This is just going to increment every time the value is not that node, right. Okay, so let me just really show you what it is. So let's say we want to get the value, let's say define. I'll just do this one, and the next thing we'll do is to solve these questions here, right. I'll try and solve these two questions, which are very linked list based questions. So let's see, we want to get, let's say, for now we have uh, quite a number of nodes in our linked list, right? In fact, we can create an array, iterate through the array to add those nodes. I don't know why I never thought about it that way. So let's say we have I'll call these nodes, right, and set it to an array, and I'll just pass this 1, 2, 3, 4, right, and I'll iterate through this array to add each one of them to the node. So let's say for I, or let's say for nums in nodes, right, like this, we simply need to do list dot add, sorry, not that list, this bigger list. So list dot add node, right? We want to add node nums, so we don't need to repeat all of this every time. So now we can see we have less code to write and everything is clean. When we run this again, you can see we have all our nodes set in place, which is nice. So now what we need to do next is to get the position of an item. Let's say we want to know where the position of 3 or 2 or 4, right, in this linked list. So let's see, now how do we do that? First of all, we need to create a counter. Since our linked list does not have indexed based positioning, we need to simulate the index ourselves by simply setting a counter, right? So every time we see a node, we'll count it as 1, and each time we see another node until we reach the end of the linked list, right? Now until we get to a point where the value is equal to the value of that node is equal to the value we want to know, then we'll say, okay, we found that value, right? We'll return the position of that item. Otherwise we can return -1, which means it's now part of our linked list. So let's say I'll define that function outside again. I'll say get position by value, right? I'll say get position by value, and I'll set this to first of all, we want to look at a linked list. So I'll first of all take this function will take a head, right, and the head is simply an instance of the node class. So and then the get position by value, right? So we want the value we are trying to look at, so I'll put the value there. So yeah, so let's see what else. So since we are going to access the first item in the node, or in other words the head, right, I'm going to set that as 1, right? So the first item in the linked list, I'm just going to set it as at position 1, right? So let's say position get position by value. So position is simply going to be set to 1, right? This is the first node in our linked list, so I'll call this current node, right? The current node is simply going to be the head, right? And then I'll iterate, right? I'll start traversing the node. So while the current node is not none, in other words, while there's a value in that particular node and it's not none, right? Now if the current node dot value, right, is equal to our value here from the function, then we just return the position at which we found it, right? Position. Otherwise Otherwise we keep iterating, so we'll keep setting it to the next node. Current node should be equal to current node dot next, right? And we also need to increment the position each time we traverse the node. So position is simply position is simply going to be equal to 1, additional 1 plus 1. So in the case where we finish iterating or traversing the nodes and we don't return anything here, we can simply return -1, which means we did not see that particular item in our linked list. So let's try this out and see how well we'll do with this. So print head, right? And let's say we want what did I call this function? Get position by value. So get position by value, and I'll pass in this list dot head, right? Dot head, and I want to get the position of number 3, so it should be at position 3, right? So I'll pass in 3 here. Okay, so I'm not printing out anything, so I'll just set this to I'll say position results is simply going to be equal to this, and I'll print the position, print position results like this. Okay, let me set this to a function. Okay, it doesn't matter anyway, so I'll say here, okay, let's just leave it like this. I want the position of the of 3, right, or node 3. So let's run this, and you can see this is printing 3, but it's putting it at the end of this. So the reason why it's doing that is because we ended. So let me just print an empty space between them so that this comes on a new line, right? So now you can see we have 3 here as our node. Let's test this out. Let's say we are looking for 35. So this will simply give us -1 because 35 does not exist, right? -1, and yeah, so that's about it. If we want the first item, right, so if we put 1 here, right, the first item in the node in the linked list is here is 1, right, which is this here. So when I run this, you can see 1 is at position 1, which is really cool. So now let's see how to how we can solve this problem, right? So that's just a basic revision on linked lists, which is very, very essential. So let's see how we'll perform some deleting nodes from a linked list, right? So remove duplicates from sorted linked list, right? So how do we do this? Let's say we have a linked list like this. So I will write this out here. Let's say we have a linked list like this. So this is going to be I'll call this 1, 2. So it says the list is sorted, right? List is sorted, so this is good. So 3, I can put my duplicate here, right? So 2, and then let's say 3 here. We want to remove the duplicates in this linked list, right? So how do we do that? Again, one thing about linked list is you should always think about traversing the list first, right? At least that's my trick. I always think about traversing the list before fully getting the full picture of the problem, right? So for us to remove duplicates in the linked list, right, we need to know where the duplicates occur, right? So now for us to know where those duplicates occurred, occurred in the linked list, we first of all need to know where our linked list started from, because we can't simply access the duplicate. Let's say in this case the duplicate here is 2, right? We saw this 2 first before we saw another 2, so we'll always have to start from the beginning, traverse our linked list until we get to a point where there is duplicate before we delete that duplicate from the linked list, right? So how do we delete the duplicate? Well, we simply need to first of all start from the beginning. Like I said, check the next item of this current node. The current node here is going to be 2. The current node here is 1, which is the head. So we check the next value of this current node. Well, the next value here is 2, so the next value is not the same as our current node, right? So we simply put it there, and then this will become our current node now, right? This will become our current node, and we'll check its next value. Now in this case, the next value of our current node, which is 2 here, is also 2, so they have the same values, right? Which means they are duplicates of each other. So all we need to do is to remove this current node from here by simply shifting the next node after the duplicate to the node after it, right? So we'll simply change the next value of this node to the next value of the duplicate, or of the node where the duplicate occurred. So we'll simply take this node and set it to the 3, right? So by doing it that way, right, we simply removed the duplicate from the node, right, or the linked list. So yeah, and that's all we need to do. So traverse the node from the beginning, check each node, right? Check if the current node's value is the same as its next node, right? If it is, then set the next node's value to the current node's next value, right? So, and one thing you might be asking, okay, what if we had 1, 2, 2 again, and then another 2? Now this is not the same as finding duplicate, right? A duplicate is simply when something occurs twice, right? Or when there's an occurrence of a particular node 2 times, then that's going to be a duplicate. So we are always sure that the next node, right, of the current duplicate is simply going to be a different value, right? We are always sure of that because the array is sorted and we are told to remove duplicates and not remove every occurrence of a particular number or item in the linked list. So here's the solution for that code, right? I'll write out the solution again step by step to explain how it works. So let's say, for instance, I'll bring back my linked list here, right? I'll create so let me introduce some duplicates in this linked list. So I'll say this linked list here is going to be so instead of putting this, I'll just put a 2 here, right, so that we can have the duplicate. Now you can see we have a duplicate in our linked list. So let me remove this one here. I'll simply comment it out, right? So let me comment that out, and let's say I want to remove duplicates, right? I want to write a function that removes duplicates from a linked list. So here's what we need to do. We simply need to define what do I call this? Delete duplicates, right? Delete duplicates. So I'll say define delete duplicates, and this is going to be passed. So we'll give this this method a head, right? So oh my god, we'll give this a head node, and this is going to be an instance of the node class. And yeah, so all we need to do is set our head to the current node, right? So say current node always, I like to do this, is set to the head, and then we'll begin traversing the head, right? So now the only conditions that will allow us to traverse the head is if the current node, right, has a next value, right? If it has a next value, then we'll begin traversing the head. So Now let's see what happened. So I'll simply come here and say, okay, since we are here, here's what we need to do. Now we'll say if the current node dot next right, if the current node dot next so if the current node's value, right, because we want this, if the current node's we want, okay, this is our current node, right? If the current node's next value is the same as our current node, then we remove that node from the linked list, right? We remove it from the linked list, just like I did here. So if the current node of value is equal to the next node's value, right? So if the current node of value, sorry, let me say val is equal to our current node dot next dot value, right? The next value, then we simply remove it from, we simply set the current node dot next, right, dot next to be equal to the current nodes dot next dot next, like this. So we set to the next of the next, right? So otherwise we just simply set the current node to the next value. So current node dot current node should be equal to current node dot next. So that's all we need to do, and I will say at the end of the day we'll just return the head, right? We return the head of the nodes, and let's print this out. So let's delete duplicates from our node here, from this list node, right? And then we'll print those out again. So I'll say so after deleting we'll have a value, right? So I'll say new nodes or new lists is simply going to be equal to delete duplicate, right? And we'll pass it the list dot head, right? And then we'll just print this out, print print new lists, because we can't do we are not doing new list or head because we are already returning the head here. So let's see how this goes. Oh, hold on. What's going on? Oh, so there's no value here. Sorry, it's val. Okay, now you can see this is being printed out. For some reason we are not getting the actual linked list. New list, I can't do new list or head, so this should have, oh, this is print, it's not print list. Okay, sorry, my bad. So we'll have our actual linked list. Now you can see the duplicate has been removed, which is this 2 here, right? We removed 2 from our linked list. So that's how you solve this problem, which is LEETCODE 83, remove duplicates from sorted list. So I'll come back here again, right? Let me remove this, and I'll set this to I'll create a new file. I'll call this leet-84. Is it 84? 83, remove duplicates from sorted linked list. So 83 remove, sorry, 83 remove okay, remove duplicate from sorted sorted dash linked list. Okay, so let's repeat that one more time. I'll just take this here. Okay, I'll copy everything here just for the sake of it. Put this here, remove this from here, right? Remove optional, we don't need optional at all. So oh god, Let's see, S. Right, no. Shift S. Okay. I wanted to select those things and delete them. Anyways, they are gone now. So we set our current node to the head. Right now, if our current node has the next value, so while current node dot next, right, if our current node has the next value, then we'll say if current node, right, if the current node dot value, right, is equal to the next node's value, so current node dot next dot value, right, then we set the current node next dot next, right, to equal to the next node of where the duplicate occurred. So current node dot next, right, like this. Otherwise, we simply will say current node, right, current node is going to be equal to current node dot next, like this. Okay, so that's all, and then we return the head. So return the head, right, so like we did here. So current node the next value, we delete it. We simply remove it, we replace it by the next node, we replace it with the next node. So yeah, that's all for question 1. I'll just simply git add git commit -m I'll call this linked list, right, LEETCODE 83, right, was it 83? Yeah, 83. remove duplicate, right. Okay, so that's it for question 1. And then question 2 is quite similar, right? So what question 2 says is to remove, given a linked list and an integer value, remove all nodes of the linked list that has the node value equal to our value, the input value here. Hey, hello. All right. I don't know how to pronounce your name, but Night Rats Gaming. I still have you in the stream. Welcome. Alright, so let's see what we can do here. So for us to be able to delete a particular value from our linked list, let me bring this here, right, to be able to explain that properly. So I'll come back here, I'll remove everything we have here, right. Now here's our linked list. Oh my god. Okay, so this is a linked list, right, and we're told to remove every so we have a linked list as our input, and our inputs are the linked list and the value. Let's say in this case we are targeting 6, right? So 6 is going to be the second integer that we want to remove from our linked list, right? So this is our linked list, and the value here is going to be equal to 6. Now, so how do we remove a particular value from a linked list, right? Given that value can occur at different position in our linked list, right? 6 is here, 6 is also at the end here. Now, for us to do that, again, we need to traverse the beginning of our linked list, right, from the beginning towards the end. And every time we encounter this value, we are going to remove it from the linked list by simply replacing it with the following node, right? So now, how do we account for cases where the value we are removing from our linked list uh, might occur at the beginning of the list. So let's say we have 6 here, right? Instead of the links being like this, we have it starting from 6 all the way to this point here. Now, which means we have to also remove the first item from the linked list. Now, when cases like this arise where we'll have to remove the first item from the linked list, the best thing to do is to have a copy of our linked list, right? So we'll need to copy this linked list somewhere, right? And then traverse that particular copy and remove every occurrences of our value, of our target value, right, from the linked list, and then we will return the head at the end of the day. So let's see how we can do that. First of all, we'll take this linked list, right, and we'll copy it, right? We'll copy it to a new list. Now that new list, we are not simply going to create a new let's say we instantiate a node, right? I'll call this a node. Essentially what linked list is just a series of nodes, right? So we have a new node, right? But this node here should have a next value set to the copy of our actual linked list, right? Now we are not going to set the value of this node because we don't really need it, right? We simply want the next value of this node to be our original linked list, right? So I'll put original list, right? Original list like this, and then we'll begin traversing this copy here. I'll call this copy, right? We'll begin traversing the copy and check if the next value of this copy here is actually equal to the node, right? If if the value of this, the next value of this copy here, right, is equal to the value we want to remove from our linked list. Now this will help us remove the first node from our linked list if that node was supposed to be our value or our target value, right? So let's say for instance we did this. So this node here, right, we have a node equal to the node value here. We don't really care about that. We want the next value of this node, and we set this next value to this entire linked list, right? So this 1, 2, or let's say we'll put 6 at the beginning, right? So 6, 1, 2, and then another 6, and and so on, right? Now when we begin traversing, right, since this is our current linked list, right, we'll simply say L dot, I'm calling it L dot next, right? L dot next is simply going to be equal to this 6. Now if L dot next is equal to our target value, which is 6, then we'll remove 6 from our linked list by simply replacing the current next, right, with the next of the position where we found that duplicate, which is what I did here, right? So you can see I've already submitted this. So I took a copy of our linked list, right? I created an instance of a node class, right? I set the next value to our current linked list, right? And then I just put this I set this as the current node so that I can traverse this node and reset its value each time. So when I find a next value, right, when there is a next value, then there is a chance that that next value has a value equal to our value, our target value here, and then we simply set the next property of that particular node to the next value of the nodes after it. So, and otherwise we just set the next to the next. And the reason why we return head dot next here is because our head really started from this point here, right? We did not have a value for the head, we simply started from the next. So let me show you how to do this, right? I'll simply come here, I'll copy our node, I'll copy, what number is this? This is, oh sorry, this is another question. This is number 203, right? Number 203, linked list. So I'll put this here. So I'll say lit dash 203 come on, remove elements, right? So remove dash elements. Okay, so here you go. I'll simply take this part. Hold on. Yeah, I need this. I mean, okay, let me just copy the one from LEETCODE here. I'll copy this here from this part upward. Okay, here. From here towards the side here. And set this like this. I mean, we don't need the optional parts because we don't have those optional classes. I mean, we don't have those here. So I'll just take this and set it to this. This is going to be the list node. And then here is what we need to do. We first of all create an instance of our list node. So I'll call this new node, right? Or new copy node. Okay, and this is going to have this is going to be an instance of a node class. This is just going to be a node, and what we need to do is we need to just set the next value of this node. So basically we can have 0, right? 0 as the value, but because 0 is already set here by default, so we don't really need that. So it can be like this, or we can set it to 0 by ourselves, but it doesn't really matter. 0 is set here by default. So here's what we need to do. We then take we say the new copy code, right? The new copy node will have a next value, right, set to the head of our current linked list, right? And then we'll just have a copy of this like we have as usual. So we'll say current node, and this is what we'll use to iterate through the entire node, right? So we'll say current node is simply equal to the new copy node, right? New copy node. Should I call it new copy node or new node? Anyway, it doesn't matter. So sorry. So after having this, so we traverse this current node, right? So if this current node dot next, right, if this current node has a next value, then here's what we need to do. We simply need to check if the current node dot next value, right, the next dot value, right, dot value is equal to is equal to this value here, right, which is this value here. If it is, then we simply need to replace that node, right? We say current node dot next, right, the next should be equal to the current node, like we do as usual, dot next like this. Otherwise we simply need to set new values to that node. So current node, the current node will simply equal to current node dot next, and at the end of the day we'll return the current node's next value. So return current node dot next. So this is all we need to do to remove the duplicates from the linked list, right? Yeah, so I just did this to have a copy of this. When we run this now, you can see this works, right? It passed all the test cases, and we can submit this again. And yeah, so the solution actually works, right? You can see the runtime is not bad. Memory wise, I'm not sure why it's like this, because maybe because I'm creating an instance of the list node here. I'm not sure, but yeah, it works just fine, right? And it's quite similar to what we did previously, right? You can see, to remove a node, we simply set the next of the current node to the next of the next node, right? We just do this to remove the node, and in this case we are just simply checking for duplicates. Meanwhile, in this case we are checking for a certain value, right? You can see they're all the same. They are all the same. They're all the same. So I will just push this to GitHub again. So git add git commit -m lead. So this is also a linked list question, linked list, and we'll set this to LEETCODE 83 dash remove dash duplicate like this. No, sorry, yeah, remove node. I'll call this remove node. Yeah, remove node, and we'll just push this to GitHub. Git push origin main. Okay, so this is all we need to do, and this has been pushed to GitHub. Yeah, so that's about it for today. This session has come to an end. I hope you've learned a few things, right? Delete bookmark. I hope you learned a few things from this section. And yeah, so tomorrow I'll be starting with a new topic, which is going to be on, let me verify that quickly. I'm sure it's going to be trees from LEETCODE. So trees, yes, so I'm going to be doing trees and so on. Anyways, I'll see you guys tomorrow.